So a little bit of a false start there, but that's about par for the course as these things go. Evening, y'all. Welcome back to another Electronics Bash Fundamentals of Electronics Design. Hi, Dave. Good to see you. Dave, I waved to the side as if you're over there, but of course, for the camera, it doesn't really matter. It's going great this week, as always. We're gonna have a good time this Sunday night. The beer is ready. The technology is mostly ready. A bit of a false start there. Yeah, so a few technology issues this week, especially a little one to do with the microphone that my very generous wife was helping me troubleshoot up until about 10 minutes ago. Then we went live and there were some frame rate issues, so I stopped things and restarted them, and that seems to have picked things up. In any case, if things go wacky this week, as they certainly have many times before, let me know and we'll figure out how to fix them. I have a backup microphone it's really not classy, but it will work in a pinch, so we can use that if we have to. I don't have a backup internet, so if anyone has a spare internet lying around other than Kenneth, but I don't think he's with us tonight, let me know and we can switch to that if we need to. But tonight, we're going to talk about regular expressions in Python. At least we're going to talk about regular expressions. We're going to talk about it through the lens of Python and Raspberry Pi programming. Regular expressions are a concept that is common to many programming languages. So if you are not a Python head, or if this is your first time joining us, or you're just interested in getting involved in learning how to process data using regular expressions, this should still be useful to you. Some of the specific syntax, of course, will be Python specific, but the language that is regular expressions is pretty much common to all modern text-oriented programming languages, and we'll see what that means in just a little bit. Yeah, the other thing that may happen tonight is, of course, so I have my face that you're seeing, I have my computer that we're seeing with the stream stats there, which don't really matter to anybody but me. We also have the Raspberry Pi set up to capture, so we can see the live desktop of the Raspberry Pi in real time. That is probably, as we've seen before, the weakest link in all these things. So if that capture goes down, and it may, then we will switch to doing the same Python code, but on the streaming PC. It'll be exactly the same, it just won't look exactly the same, because Python is Python, but the capturing, as I said before, the way that the Raspberry Pi handles resolutions doesn't quite play nice with my capture card. You don't need to know any of this, but if things go blank, don't panic. We'll pick up from there. What it's doing now, this Raspberry Pi screen here, is running a program that has been running since about sometime yesterday. I guess we'll go in and find out later tonight when it started. But I wanted a little bit of text-based data to work with this evening as we were learning to use regular expressions to parse text. And so I've got a little... let me see here. I've got a little PIR sensor here, a little passive infrared sensor that's detecting my presence, essentially my motion. And then I've got a little temperature and humidity sensor here that's been logging temperature and humidity data. The temperature and humidity is not going to be super interesting, I don't think, just because, for obvious reasons, it's not changing temperature too radically in my little workshop here. But I wanted us to have sort of interesting data, this PIR data, this presence data, so that we could sift through a sort of sea of other temperature and humidity data to try and find. Because one of the things that regular expressions are really good at, as we'll see, is pulling out just the critical information that you need from a sea of other data. So after this has been running for, I think it's 12 hours now, I'm going to kill this process so we can see our IDE, and we'll start looking at regular expressions. So we'll close that. Well done, little process. You ran a good long time. We got some coding to do. Okay, so what the heck is a regular expression? Let me get this a little bit bigger here. There we go. Get that table out of the way. Let's start with a very simple program. And I should say, for those who maybe are joining us for the first time, or maybe those who need a refresher, because it's been a little while since we've done Raspberry Pi-based stuff, all of the code for tonight is on the website, jeff.glass/electronicsbash. The weeks that have slides to go along with things, the slides will be up there as well. This week, there really aren't any. We're just going to be doing this all in code. So if you'd rather follow along with the code on your screen rather than on my screen, as it were, feel free to pop the code down from there. That might be an easier way to follow along. So let's start with a very simple program. I'm calling it the Hello World of regular expressions, which has sort of the basic framework for working with a regular expression-based program that will sort of explain all the key parts of. The first thing we're going to do is import our regular expression library. In this case, it's the RE, regular expression module. It's part of the Python standard module. There's nothing additional to download or install. And let me just show you what the basic parts are here, and then we'll go through and explain them. I have this sentence here. It's like, it is traditional for your first program to say hello world world to the terminal. I've got a pattern, and this will be a thing we spent a lot of time with this evening, saying re.compile. I'm giving it this string with an R in front of it, which I will take a moment to explain, of hello world, and then I'm going to print out re.search pattern, comma, sentence. And if I run this, it gives me this match object with a span and the match hello world. Now you might be sort of starting to get the gist of what's happening here already, but just to make it explicit, the re.search function is looking for instances of this pattern, in this case the compiled version of hello world, inside our sentence. So we pass this re.search function two variables. We give it a pattern that we're trying to find and a sentence or some data that we're trying to find that data in. Now, of course, the sentence doesn't have to be a literal sentence. It could be many sentences. That's just my stand-in for it's some text data, some string that we're searching through. And by pattern, well, this is really the meat and potatoes of the regular expression library. The reason that we're using this re.compile method is that a regular expression isn't just a string like other Python strings. It can contain lots of other information for how we like to identify patterns in the sentence or the string data that we're searching through. The first thing that I wanted to throw out, I mentioned we're using this string with an R in front of it, which we hadn't seen before, and that just means that we're working with a raw string. In Python, we have seen before where we're able to insert special characters into the middle of our strings to give them certain shorthands for non-typable characters. So for example, /n is our shorthand for a new line. So I could say hello /n or \n world. I'll print that out after the rest of our code. And when I run this, we'll see we get hello, a new line, and world, right? Similarly, we have /t, which is a tab character. And if I do hello /t world, I get hello, a tab space, and world, right? Because it's hard to indicate that I would like to type a tab with my keyboard. We just have these /n/t, and there's a few other special ones in here. For the sake of creating a pattern that we want to match against, however, most of the time we want a slash to really represent a slash and a t to really represent a t, or a /n to represent an n, and so on. So in this case, what I'm using this R for is to tell Python, hey, don't do any fancy interpretation of what anything means inside here. Just give me back exactly what I asked for. Treat it as raw data. So if I say hello /n world with this as a raw string, I get hello /n world, right? So that's all that R is. And this compile is going to be interpreting the bits and pieces of this raw string in various creative ways. And that's what we'll be spending most of our time on tonight, is how we're using this compilation method to generate interesting patterns to match against. This shows the very the most basic pattern, which is just a literal string, right? There's nothing funky going on here. It's a string called hello world, and we're finding where that string is in our sentence or in our data. And maybe we'll change the name of this variable to data, just so it's a little bit more clear that it doesn't have to be a literal sentence, right? So if I run this code, we see that our search function, re.search, returns one of these match objects, which tells us that it found our string, our hello world string, inside of our data, and the span of characters that it was found at. So in this case, the span starts at character 50 and does not include character 61. And we can see that if after this we say print data from character 50 to 61, we should get, let's find out, hello world, right? Exactly the string we searched for. So this is a very basic way to use the search or other functions here. Now, what if I wanted to find not just one instance of a string in my data, but I wanted to find all the possible places where a string is found? Perhaps, in this case, I'll use the word to, because I have your first program to say hello world to the terminal. If I just use re.search, we only get the first instance of that literal string in our data, right? I only get strings 41 and 43, and that's going to be our first two up here. What I'd really like is a method that gives me back all of the possible matches in our function. There are a couple of different methods which will do this. The find all method, I believe will give me every match, but it will really just return the strings themselves. If I use the find iter method, it will give me back an iterator, which goes through all of these match objects. So we haven't talked super much about iterators yet, but know that you can cast them to a list. If we want to see them all. This is the easiest way to do it. In fact, why don't we say, we'll say my matches equals re.findIter pattern data, right? So I'll have an object that can give me back all of the possible matches that it's found in my data there, and I'll say for m in matches print m, right? And we see now we have our two different matches. We have the two say hello world to the terminal at span 41 to 43 and span 63 to 65, both of them matching just the literal word to there, right? So I'm going to be using this find iter method a lot in tonight's chat, mostly because, you know, well, we could use find all and have this where it just tells us the words that it matched, and that's fine. And in some situations, that's a more easy thing to deal with, but I think it's more useful and more informative to have this additional data provided by these match objects that the find iter. Find iter essentially returns you a list-like object that you can use to go through all of the matches in your data. You just can't print it out directly. You just sort of step through it one by one, and for each match that you found, say in this case, print it out or do something else with it, right? So that's the basics of it. And I think there is a separate example on the website doing using the find iter method. Let's see. What did I say here? Yeah, so in the sentence, for example, sometimes it is useful to find not just the first match in a sentence, but every match. The find iter method returns an iterator containing every valid match. So if in that sentence I search for the compiled pattern match, I will should find 3 matches at characters 52, 83, and 156. I have match, match, and match, right? So hopefully that makes sense so far. I guess I should say question so far, and as those of you who've been here before know that asking for questions is just my excuse to pause for a quick sip, to wet the whistle before we carry on. Tonight, my whistle is being wet by, let's see if this works, yeah, by the Chicago Common Style beer from Kinslogger from an incredible meat market down here on Lincoln Avenue in Chicago. So always happy to support a local Chicago store and a Chicago beer. So questions as I wet the whistle? As always, I want to know if you're drinking something interesting out there tonight. No pressure to. I know drinking is not everybody's thing. It's something I enjoy, a nice beer with some programming. So if you are, great. If not, maybe hydrate. Hydration is cool. Hydration. Hey kids, hydration is cool. So the find iter method, as we were saying, returns an iterator for all the possible matches in your sentence, in your data, what have you. I'm going to take a little quick peek at my cheat sheet here, see where we were going to go next, because there's lots of little parts of things that we can talk about. Nate, hi, Nate, good to see you. Let's see who else is here tonight. Dave is baking bread. Ooh, so Dave, you are going to be enjoying the products of yeast fermentation, it sounds like. Well, that'll be tasty. Ooh, Chris, is Dragon Soul Bond a drink or a religious commitment? It sounds like you're getting into some like mystical magicalness over there. Let's see here. What do we want to talk about next? Oh, let's talk about special characters next. So far we've been matching these literal, strings. Just the word match. We could also match much shorter things. We could match every instance of the letter A in our sentence, or every instance of the characters OR, which match iterator here, the OR and iterator. There's no reason that we have to match a whole word. We could also match, the combinations of things. If I match a sen, right, I should get one match, which is the in a sentence here, right? Let's happen to match any string of characters we like. There are some characters that we are not allowed to just plop in here. For example, if I wanted to try and match, say, the period at the end of match, if I put a period in here, instead of getting just one match, it looks like it's matched pretty much all of, oops, get out of there, all of the characters in our data. And in fact, that's what it's doing. Period is a special character with special meaning in our data. There's actually a number of characters that have special meaning, so let's go through them because they're going to prove useful to us, and I'll show you how to search for them if you want to just, find the period in your sentence. The special characters are all 3 kinds of brackets, parentheses, brackets, and curly braces, the backslash, the vertical bar, the period, asterisk, plus, question mark, and the caret, right? Now, any of these, if we want to search for, say, just the so here's an example, right? If I wanted to find where in this sentence I'm saying this find iter method relies, right? If I try and search for that, I just get find iter. You see it's not actually matching these quotation marks. And if I just match the quotation marks, right, I get, again, a series of lots of matches, which is not what we want. To tell something that this is a literal punctuation mark, or this should not be treated as a special character, we can introduce a backslash in front of it. So in this case, I would say backslash parentheses, backslash parentheses, right? And in this case, we should just get one match, which is our pair of parentheses over here, right? Similarly to our early example, if I wanted to find just what character position the period in my sentence is, I can do backslash period, and when I run that, I get just the period at the end of the sentence, right? So if you're ever looking to just find some brackets, some punctuation in your text, you can always escape them, is what this is called, escape them with a backslash, and that says, hey, rather than obeying the special rules in that these characters would normally cause you to do, and we'll be going into all of them tonight, just escape from that logic and just treat this as a normal character. Chris asked a good question. Can you find spaces? You absolutely can. Space is not a special character. So for example, I could search for it is in my text, and I see I get the match it is from sometimes it is useful. There are, and this is a little bit esoteric, there are certain modes for searching where you treat the spaces between words and new lines, like actual enters and carriage returns, differently. But most of the time we'll be operating in what's called single line mode, where you don't necessarily treat them as the same, as different. You treat them as sort of the same thing as a gap between other letters. But spaces are, any white space is really quite straightforward. Speaking of white space, let me show you something cool. Let's say we wanted to search for, let's see, what's going to be a good example here? Let's see. Maybe I made one up earlier if I'm quite clever. Yeah, I did. But let's ease into this just a little bit at a time. We have a handful of ways of searching, not just for literal text, because if this was just a way of searching through strings for like literal words, I mean, it's cool. I mean, I guess it's useful, but it's not super powerful. We start to expand our possibilities with regular expressions when we start to develop this pattern language a little bit more. And here's one way we could do it. We can represent groups of characters. We can represent certain classes of characters in certain ways. Rather than matching, for example, let's see, how do we want to do this? Let's say I wanted to extract every word in this sentence that starts with the letter T, for example. In this case, I think that's just to and the. Oh, maybe let's do letter S, right? So we'll get sometimes and we'll get sentence, right? How could I match something, create a match that matches both sometimes and sentence? Well, there's a couple things we do. I mean, one thing we can do is just like match them both separately, right? You could say sometimes I get one match, and I've got a sentence, and that's another match. Then my code could like find them both and do something with them, right? But maybe I'm creating a company document for some really awful highfalutin new startup that insists that their logo is an S, and every time there's an S in their company document, it has to be replaced by this special logo. Bad idea, but you as the programmer might be tasked with doing such a thing, right? What we'd like is a structure that really finds any sentences any words that start with the letter S. We only want to do this at the beginning of words, let's say. So rather than having to do each of these words individually, we can use what are called character classes to make our lives a little bit easier. To simplify this example, I'm just going to decapitalize that first one. So really what we want is any word that starts with the letter S, then it's got some more number of letters, and then something that's not a letter, a space, a period, the end of the string, something like that. To represent a character which is a letter, a word-like character in the language of regexes. Yeah, Chris is going to ask about upper and lowercase. We'll get to that in just a little bit. There's a couple different ways to handle it, but I'm going to elide that until we know a little more. To represent a word-like character, we can use the /w command. And this is where we start having to use these raw strings, because /w might mean something different to how your terminal print things out, but we just want to be able to compile that /w into a word-like character, right? Similarly, a non-word-like character is a slash with a capital W. So here, let me simplify my sentence just a little bit here for the sake of an example. I'll comment all of this out. In this case, let's say data equals C as that, right? Just give ourselves some words to play around with here. And we'll do a more complicated example in just a moment. So what our pattern here is going to match is the literal letter S, followed by any single word character, followed by any character which is not a word character. So a white space, a piece of punctuation. This essentially means, digits and letters, something you could type on a keyboard with your hands. That's a letter or something like that. So when I run this, hopefully what I'll get is, so I get SO space and SI space. Right? I get SO and I get C. And S, a literal letter S, right? This S doesn't mean anything special. It's just a literal letter S, followed by a word character, followed by a non-word character. We'll see this pattern wouldn't match something like saw, because that is a word character, an S followed by a word character, the letter A, followed by another word character, and that doesn't match the pattern that we're starting to build up. You can start to see why we called this variable pattern, right? Because it's not anymore just a literal string that we're finding in our text. We're building this patterning language with our regex commands, right? There are a couple other character classes, and I'm going to have to invent a couple of examples here before we get back to our matching any words that start with S example here. Some other useful ones are /d, which matches any digit, right? So if our data was instead a sequence of digits, right, we can see it matches any of those individual digits. We could also have it match a pair of digits, right? 3, 4, 5, 7, 8, 6, right? And those are the pairs of digits in our number. And this is actually a really good point to point out. When the, at least the find iter method of regex pattern matching, this is generally true, has matched some characters as being part of one of its valid matches, they are no longer in play for the pattern matcher to find those characters as a match again. So what I mean by that is, right, our pattern matcher was working its way through the string. It said, I'm looking for 2 digits next to each other. Okay, 3, 4 counts. It's not then going to match 4 and 5 because the 4 is used up. It's already in a match. We're not going to see it again, right? It's then going to find 5, 7 are our next pairs of digits again. Good, yeah, excellent question, Chris. And then 8, 6 next to each other, right? So once we've matched a set once you found a match in your data, it's only going to use those particular characters once. Then it's going to lop those off and say, okay, in the rest of my data, what other matches do I have? And typically, it will work from the beginning of your data, your string input, to the end. That, I think, is also configurable. We'd have to look that up. But I think you can match from the end if you want to. The only other character class that's probably worth mentioning here is the /s character class, which matches any white space. So this is not going to print out particularly interesting. But let's go back to matching against our sentence data. And when I print it out, we'll see that the matches are literally all of the spaces in our sentence. So the /s character, the white space matches against spaces, against tabs, against new lines, anything that's a separator between words. And that can be really nice, if you've got something like this that's separated by spaces and there might be tabs or new lines in there, but we mostly want to make sure that we have a break in between words. Oh, hey, Kenneth, you are here. I knew if I was just a little bit, I knew Kenneth would rear his head with some snark at some point. Yeah, here. So here's all the white space, Kenneth. That's just for you. I'll print it out again if you would like. So that's a useful character to have. So, for example, let us jump over into our character classes example from the web, just because that's a slightly more useful sentence to look at here. This sentence is a little bit academic, but it says, I tried to call 1, 2, 3, 4, 5, 6, 7, but I accidentally called 7, 6, 5, 4, 3, 2, 1. When the person picked up, they said it was 1-800-765-1111. How that works, I can't recall. A classic bit of storytelling. You shall see, hey, Thomas, good to see you too. Good, yeah, listen, even if it's just snark, I love all y'all. Feel free to chime it in. Well, most of y'all, you know who you are. So let's say I wanted to find all of the 7-digit phone numbers in this sentence, right? So things which are 3 digits, then some kind of separator, right? And we'll see we have a curveball here with this underscore, and then 4 more digits, right? So I might create a pattern like this, which is 3 digits, in this case a hyphen, and then 4 more digits. So /d/d/d, a hyphen, /d/d/d/d/d, right? 3 digits and then 4 digits. If I match this against our sentence here, we'll see we come up with at least 2 phone numbers, right? The 2 places that match 3 digits, a hyphen, and then 4 more digits, right? We haven't matched this one, of course, because it's not separated with a hyphen. It's separated with an underscore. But you can see how this is a lot, it's a relatively flexible way of defining the pattern that we're looking for. Now, I guess, sip time, questions so far. We're going to kind of roll through a bunch of topics really quickly, and then we'll do some sort of synthesis examples at the end, I think. We're already on like 4 of 8 examples, and we're flying. I feel like I'm maybe getting a little bit ahead of myself, but let me know if you have questions right now as I take the sip. Well, now we're not muted, but I'll bet by the time, yeah, Chris, got in there. I can tell how long. If I ever am worried about how much lag there is, I'll just leave myself muted and start talking and see how long it takes for people to chime in. Oh my goodness. Well, thank you all for trying. I should say, if I ever just completely fail at noticing, you can always call the bat phone. The number's on the screen. I will say, exciting personal news, I did get the shipping confirmation for the red handset and red cord for these. The cord is new, but there's an actual new old stock AT&T handset coming my way, so I'm excited for that. So anyway, if I ever screw up, or you think you see me fall down in a faint because I've programmed so badly, just call the bat phone and we'll see what happens. The reds won't match. They won't when I get them. With enough age, though, I think we can make that work. Or if only I knew somebody who knew about like getting colors to match on physical objects, Chris. In any case, we've abandoned our earlier example a little bit here, but I think this one would actually be a little bit more sensible to start with, right? In pulling out these 7-digit phone numbers, Dave says, can you find the odd pairs? Ooh, that is a good question, Dave. Let me come back to that just a little bit, actually. I think we'll have better luck with that in just a little bit. In this present example, right, pulling out our 7-digit phone numbers here, we have one obvious flaw and one that is not quite as good. So the obvious flaw, right, is we didn't match this, whoever typed up this message to me really did a bad job of formatting. They put an underscore here instead of a hyphen. And so really what I would like is for this character in here, this hyphen, I really like to be able to say, okay, this could either be a hyphen or an underscore, or maybe something else. So let me show you how to match on multiple options for a single character, right? Right now, this is matching the literal character hyphen. If I want to match one of a number of characters, I can use square brackets, right? And any grouping in square brackets will match to Thomas was making a good point. We could also match to anything that's not a number, right? So we could say square brackets hyphen underscore. So this is still representing a match to a single character, but it's saying it could be any one of this class of characters. This set of characters I've had here will be a hyphen and an underscore. Now, if I match to that, I should get our 3 phone numbers here, 123, 765, and our last phone number down here. Thomas also makes a good point. We could also match anything that's a non-digit character in the middle here, and there's a shorthand for non-digit characters, just like there's a shorthand for non-word characters, which is /D. And again, that should work, right? I should get our 3 phone numbers down here. So that's certainly another way we could do it. Maybe this is something this is all going to start getting into like implementation detail, right? If someone in the sentence says, but numbers with 765 and 1111 and 42 aren't, that's 43, 42 aren't valid, or something like that, right? Do I want to match against this number? Probably not. On the other hand, how likely is this sentence construction going to be? Is this sentence going to be the data we have to deal with, right? So whether you want to be exclusive or inclusive about what characters could be here, a design choice left to you. The other sort of slightly smaller problem that we're having with this set is, I don't know about y'all, but staring at enough of these /Ds long enough, my eyes start to go a little cross-eyed, right? Like I I can't, it's like, is it 3 and 4? And especially like if this was a situation where we're trying to match 12-digit serial numbers, something like that, this just becomes a very unwieldy way to write this. Thankfully, there is a syntax for matching on multiples of the previous matched value, right? So rather than saying /d/d/d, I could say curly brackets 3, which means I'm looking for exactly 3 of whatever my previous matched object is here. And that could be that could be a /d, a /s. This could be a literal character. I could look at your 3 G's in a row and so on. But we can simplify our earlier telephone pattern here to /d and 4. So I'm looking for exactly 3 digits followed by a hyphen or an underscore, followed by exactly 4 digits. And again, we should get our same 3 matches: 123 number, our 765 number, and our other 765 number. Chris is having flashbacks to various grep-like syntaxes. Yeah, that's gonna be inevitable there. Some other interesting things you can do with this character class notation, this brackets notation. You don't have to just put a set of literal characters in here. But you can certainly do this with not only with characters but with letters, right? So I could say match against 2 digits followed by any of the letters A, B, C, and 4 digits, right? So right now we should have no matches, but if one of our telephone numbers for some reason has the letter B in the middle of it, now we get our match: 765B1111, right? We could have our but of course it would only match on a single character, right? So this set in square brackets only matches a single character from this set of characters we've defined, right? So if I have this 765BA1111 will not match, right? We're not matching any number of these characters, we're just matching to a single one and we're defining the set. If this was the set of characters we're interested in matching though, right? And let's say this was A, B, C, D, E, F, G, H, I, J, K, right? Now our 765B will match again. I could put a 765F up here, right? And those would both match. But this is also, again, getting a little bit unwieldy, right? I don't know about you, but if I had to type out, every letter that I was interested in matching, there's a really good chance we're going to make a typo at some point. So instead, we can do a ranged match. So rather than saying A, B, C, D, E, F, and make this all explicit, I can just say match the letters A through K in that position. And the Python Regexes engine is smart enough to know that the lowercase a and the lowercase k are both lowercase characters and will match anything in the range between them. Kenneth asks, can you do ranges in the Python Regexes match set square brackets? Oh, Kenneth, I think that's the question I just answered. Yeah, so you can certainly do ranges. It's important to know that lowercase ranges and uppercase ranges are treated differently, right? So if I match my now pretty misformed telephone numbers up here, with uppercase letters down here, you'll see neither of them match because lowercases and uppercases are different in this case. You will see fairly often, patterns like match the letters A through Z, capital A through capital Z, and 0 through 9, right? So match any letter or uppercase or lowercase or any digit, right? If we want to just be explicit about what we can match in that set. But again, all of these are only matching a single character, which is one of these, right? So I could say, if I'm matching 765 and then F, right? That matches. If I 765 F G D, right, that will not match, right, because I have more than one character in that position there. Kenneth points out, oh yes, if you were trying to match on what looks like a hexadecimal number, you could use, lowercase a through lowercase f, or maybe the programmer capitalized them, so capital A through capital F, and the digits 0 through 9. And we just append them together like this, and Python is smart enough to know that it's going to put all these ranges of characters together for our use. You'll notice in my earlier example where I use dash underscore, when the dash is the first character of your set, or actually I think the last, let's see if that's true. Yeah, so if it's the first or the last character, Python assumes that it's not a range of things, right? Because the hyphen isn't between anything else, and just says, oh, that programmer probably means just the literal hyphen in that case, which is usually what I want. Inside of a set of square brackets, I should also say, most of these special characters that we were peeking at earlier, things like period, plus, question mark, of several of these special characters are no longer special, right? So if I'm looking, for example, for a someone who's formatted their telephone number like this, which is not unreasonable, 765.1111, I can just put the literal character dot inside of my character class, and we will match to that. You'll recall, right, that oh, you don't know that yet, right? I showed you earlier how the dot messed up our search, but in this case, inside of a set of square brackets, when we're defining these character sets to match against, a dot is just a dot, a period is just a period, right? We'll see exactly what it does and when it does when it's outside of a set of square brackets in just a second. Questions? Comments? Issues? Concerns? Chris says, if I remember correctly, trying to get the word after the search term, so properly formatting a number after phone. Okay. Yes, very good. So let's do a quick example along those lines, Chris. So here, let's just steal a little bit of code to start with here. But I think we have all the tools in our possession to do that. No, we're gonna need one more tool in our toolbox. And that is so we can match set numbers of digits, right? We can match single characters of any sort of class of characters we can define. We can see 1.5 more tools. I guess I lied. We can not only match set numbers of repetitions of the previous character, we can look for bounded numbers of previous characters. So in our example here, let's simplify this a little bit. We'll say in this case, we're looking for any set of 3 digits, right? We have a digit, we're looking for it exactly 3 times, and we'll get a number of matches for that. Mostly the start of our phone numbers, but also the 111s at the start of our remaining phone numbers here. But what if I wanted to look for any span of digits between, say, 3 and 7, right? So I could say, in this case, I can expand my notation here a little bit. I can say, give me a number of digits that is greater than or equal to 3 and less than or equal to 7. And in that case, I get a few more numbers captured in my search. I get still a few strings of 3 digits, but also this 4-digit case of 4321. I also get my longer 7-digit number that I have down here. So we can use this notation if we're looking for bounded quantities of some previous character. I could also use the same notation, not with a digit character, but with any literal that we're matching against, right? So in this case, maybe I'd like it to find, well, first of all, let's have it find all the letter L's in our sentence. Well, there they all are. There's a lot of letter L's. What if I wanted to find both repetitions of the letter L, right? Anytime an L finds is twice. So I could compile that, and we'll see we get 3 double L's for called, recall, and something else. Oh, called, and recall all have double L's. That's one way we could write it. We could also say I'm looking for exactly 2 L's in a row. And again, we get L, 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 L. We also say I'm looking for 2 or more L's. If we leave our second argument in this comma pair blank, it just says I want at least 2, I don't care how many. So if we turn our example here into a little bit of teen speak, right? If someone was texting this to you and they said, I can't recall, now our pattern will match call, called, and call in that order. We can also do this with an upper bound, right? I could say I want any number up to and including 2 matches, but not more. So in this case, I guess this is matching anything that is 0, 1, or 2 matches of L. So it's matching a lot of things that are not L's at all. So maybe what I really want is 1 or 2 instances of the letter L. And here we go, yeah. So now I'm getting our individual L's and our call. So this first double L will be C-A-L-L call, accidentally called double L, but we're not matching our recall, I don't think. Actually, we might be, because this would still be a valid match even if this is not. So I think so. This may be not quite the thing. I want 2 L's not followed by another L. But this is a way of doing our largest and smallest. And Chris, yes, exactly. So they are regexes in Python by default match in a greedy fashion, right? They're always, if there's an option for how many L's our pattern is going to match, it's always going to match the largest possible contiguous number for each match, right? So while this is a valid match for 2 L's and 3 L's and 4 L's, it's just going to keep going up into the greediest possible amount of L's that it can find. Chris asks, is there a way to say not when looking for a pattern? There is. The generalized form of not is just a little bit tricky. But there is a way specifically to negate character sets. So, in this example that I did earlier where I said I want 1 or 2 L's, right? And let's see how many of matches we get. Let's go back to our 2L example. I think we're still going to get, yes. So what we've got here is call. Our second match is recalled. And then these matches, 147, these are all contiguous matches. You'll see here, 147, 149, 151. Those are all the L's in recall. And what I'd really like is to exclude this answer. I just want 2 L's in a row, not followed by another L, right? Now, there are basically 2 ways to do this. One is we could say I want to match exactly 2 L's followed by any character that is not a lowercase l. And to do that, I could prepend my character set with this caret symbol and put the characters I do not want to match in this L here. So I think this will work. Yes, and now I'm matching LL, LE, and L exclamation point. And those are matching specifically call space, called, so LLE, and LL and an exclamation point here. So all the positions where 2 L's are not followed by an exclamation point. Or not followed by an additional L. That's one way you can start to tease this out. The other way uses what's called forward look ahead, which is a little bit deeper into this rabbit hole than I intend to go tonight. But for those who are curious, the syntax essentially says, find essentially this. It's parentheses with a question mark and a bang, an exclamation point saying not, and you give it a pattern and says look for this pattern not followed by this other pattern. Look ahead and look behind. Getting those ringing some bells, I think, for Chris there. Like I said, that's further along the syllabus and maybe further than we get tonight, but that is the proper way to do that. But before we get there, we have some other things to look at first. Some more straightforward concepts. I guess preliminarily, question? I don't know about y'all. I do feel like I'm flying tonight. I mean, I know time is creeping by at its normal pace, but like I'm just my mouth's getting dry because I think we're just going, which is fun. So let's see here. What else might we do? Let's go on to our next example, and partly because I think I prepared some useful sentences for myself in advance, so that will match a little bit better. Let's see. Chris, is there an easy way to say the number of matches but not display the matches? Yeah, you certainly could. Let's go back to our previous example here, and let's find the number of instances of the letter L, and we'd like to know how many that is, right? One thing we could do is say matches equals re.search pattern sentence print there are len matches. Does not have an item len. Oh, maybe I mean find all. Yes, I do, because search returns a match object and find all just returns a list. And here, why don't we put this after our search code so it pops up right at the bottom of our terminal here. There are 14 matches, 14 instances of the letter L there. So you recall that when we use this find all method, which we'll just print out the results of at the end here, what we get is just a list with all the text of all the individual matches there. And then we can just take the length of that list. That's the simplest way I know. I don't know if there is a simpler way than that. If there is, I'd love to hear about it. So let's see here. So moving on a little bit. So some of those additional special characters that I said you can't just plop into your regular expression pattern. They have special meaning. Here are a few of them, and they all modify the previous character or object we're acting against in much the same way that when we were using our our pattern here of quantity, right? It was going to modify the quantity of whatever came before it, whether it was a literal letter or a combination of symbols that mean a single character. It could also be a pattern, right? This indicator here, these curly brackets, all modify the quantity of whatever the single object is that comes before it, whether that's literally a letter or something else. Our wildcards all basically do the same thing. So we have a few different quantifiers. The asterisk will cause your regex to match 0 or more of the previous character. The plus will match 1 or more, or at least 1 of the previous character. And the question mark will match 0 or 1 of the previous character. And when I say character here, again, I mean could be a literal character, could be a stand-in for a character class like /D or /W, could be one of those literal character classes in the brackets that we're looking at. One more of any previous character representation, right? And the period, and I said I was presaging this a little bit earlier, the period matches with any character. So let's see how we can use these things. I was pretty proud of this sentence. I used a rhyming dictionary to great effect here. The panda band in the stand is grand, but the Andromeda Sand Island is pretty bland. Their brand is sandals, you understand, and the lowland androids Stan and Downland. That's a heck of a sentence, and it kind of goes off the rails right here at the end. But that's all right, because, as you might have guessed, we're going to tease apart some of these A and D sentences here using our newfound wildcards. So let's say, yeah, you're welcome, Kenneth. Got through that without falling apart. I feel pretty good about that. Let's say we want to find all instances of just the word and in our sentence. So if I use as our pattern just the literal and, of course, we're going to match anytime the characters A and D appear in our sentence, which is, well, it's a great number. It's a lot. There's a lot of ands there, and that's on purpose, right? So one thing I could do is say I want to match an and surrounded by spaces, right? And this happens to work for my particular example. But really probably a smarter match is an and surrounded by any two non-word characters, right? So if the and was surrounded by, say, additional punctuation, I would still have a match down here. So that's a relatively straightforward thing. We can do that with the tools we already know, right? Now, let's say the lunatic that is you wants to find all of the words that end in A and D, but are only 4 letters long, right? So we would have, in this case, band. We would have, is it just band? Stan. No, Stan is not a word. It just happens to rhyme, and I was making it. So really, I should just want to find the one word band. Oh, and sand. Band and sand. Thanks, Chris. So there's a couple different ways we could do that match. And an ongoing theme that you probably have already picked up on, right, is when you're creating these regexes, there are often multiple ways to achieve the same thing. And not necessarily that one of them is right or wrong. I just want to throw all the tools in your toolbox because sometimes when you get to a more complicated question, you will only have one way of achieving it. And I want you to have all the tools at your disposal, right? So one way we could approach this 4-letter problem, right? We could say, there's a way to find those words without us having to look. Yeah, for sure. We'll do some examples later on with some actual data that we just won't be able to search through everything by hand. And that'll be by hand. And that'll be a good example. So one thing we could do is say, all right, I'm looking for words that end in and I want them to start with any word character, right? And that gets us close. I get sand and band, but I also get understand, I get the end of brand, right? I'm getting the ends of all of these words as well, right? And, I could do another thing where I, prepend these by non-word characters and just make sure they split. And again, I get band and sand. And that's fine, right? That's certainly a way that we could break this up, right? I could say a non-word character, a word character, the letters A and D, and a non-word character. That constitutes our sentence, or our 4-letter and words. That's fine. What if I wanted to get all of the words that end in A and D in this sentence? And do not contain A and D. So for example, band should be in there, stand should be in there, but panda and should not. Island should, Andromeda should not. Only the words that end in A and D. And that's where these wildcards will start to come in. Rather than saying, I just want this word to have a non-word character followed by a single word character, I would like this to contain 0 or more word characters. Now that's what this asterisk is going to say here, right? It's going to match 0 or more of the previous characters. And if I run this, I should get all of my words that end in and, and are followed by single characters, right? Sand, bland, brand, understand, grand, band, and so on. I do get the singular word and, right? Because the asterisk here matches 0 or more. So this could be nothing at all. It could be a non-word character and a non-word character, right? If I wanted to say all of the words that end in and that aren't literally and itself, that have at least 4 words. Yes, Chrissy's a new line. Yeah, so a new line character, right, is a non-word character. So it's allowed to be the start of our word in this case. If I wanted to get all of the words that are not and itself, that just end in and, I could use the plus character here, right? I could say which matches 1 or more of the previous characters, right? So I have to have at least one of these word characters here. I'm not allowed to have none. When I run that, you'll see our match to just the word and has vanished, right? And if I wanted to get all those 4-letter words again, I could replace this by just saying, if it would be 3 or 4-letter words, I could say, use this question mark, which matches 0 or 1 previous character. I could say sand, band, and so on. And again, we could do this with our ranges here as well. I could want between 0 and 3 characters followed by the letters and to end my word. So I get bandstand, grand, but I don't get downland or understand. Those are too long for our matches here. Let's look at another couple examples. Maybe I'll steal some sentences from our previous text here. Maybe I'll steal this unwieldy thing. Right? Going back to the idea of matching phone numbers with arbitrary separators here, we could use our period character to match against any character in between digits, right? So I could say I want a span of 3 digits followed by any single character followed by a span of 4 digits. When I match against that, now we'll see that we get our underscore matches, our hyphen matches, our period matches, right? This period character here can be any character we wish, right? And where you start to really get crazy is if you let this period go on forever, right? So I want a span of 3 characters followed by any number of any character followed by 4 digits, right? So now I'm starting to get lots of matches there for lots of things. Cool. Question so far? I feel like we're definitely cherry picking little synthetic examples here, and hopefully when we start to string all these things together into some more practical examples, they'll start to make just a little more sense. Questions? I don't know. They call this a Chicago common style beer, and it's like a hoppy red ale, which is not normal. Red ales are not normally my thing. Pretty tasty. Let's go through. Let me just check my cheat sheet here a little bit. Yes, I think this will be a good one. So, let's talk about one more topic, which gives us some more options for how to match things. Chris says red ale Chicago. Apparently a style all its own, combining rich red malt with bold hop character. So, go figure. Let's look at this. Is going to be a now we have a few tools in our tool belt. We can do some slightly more realistic examples, and then we'll do some real examples from things I've actually had to solve in the past few days or weeks. Here's a sentence. Mr. Anderson and Mrs. Baker were discussing Montana when Mrs. Campbell walked in with Mr. Davis and Mrs. Ellis. And you notice that there are errors in both punctuation and capitalization in the sentence, and that is deliberate. We would like the option to be able to work with some real text that we might have gotten from a real source, although of course in this case the real source is me, and to what I'd like to do as our project here is to take this sentence and extract all of the names from it. Now, what is a name? Boy, is a complicated question, but for the sake of this problem, I'm going to say it's going to be any of the permutations of Mr., Mrs., and Ms. followed by a single name. Right now, how do we deal with hyphenated names and multi character names that might have characters that are not in sort of like the traditional English alphabet with various additional characters, other scripts, Unicode, not tackling that. My problem for us today is to say I would really like to extract Mr. Anderson, Mrs. Baker, Ms. Campbell, Mr. Davis, and Mrs. Ellis, right? That's the pattern I would like to find. So let's start to build up that pattern here, and we run into things we can't do yet. We'll add some more tools. Well, one thing we might do is say, okay, well, all of those character sets start with either a capital or a lowercase m. And we know how to find that. We can find a capital M or a lowercase m. So let's start by finding those instances here. Yes, and we should have, ultimately we're looking for 5 results, and I believe I'm going to have 6, right? I actually have more than 6. I'm going to have M, 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 M. Right, so I have the M in Campbell is also matching. The capital M in Montana is also matching. There's various other M's in the sentence, but it's a place to start. It's a place to start, right? So now what I'd like to do is match. So if we're looking for Mr., Mrs., or Ms., right, we might have our capital or lowercase m followed by either an R, an S, or an RS. And we don't really know, we know how to match, we could say R or S, right? We could match Mr. or Ms. And here we get our Mr., Ms., Ms. But we notice that this MR is actually the start of Mrs. Baker. So we'd want to possibly match another character here. So this is another chance where there is a couple different ways we could do things, right? We could say this matches an R or an S plus 0 or 1 S's. And that would work for our data, right? We get Mr. and Mrs., but it also matches the hypothetical of MSS, and I don't think that should be something that we successfully match. Instead, what we really like to do is to say, hey, match one of these 3 specific options, R, S, or RS together, right? And we have a syntax for doing that involves the parentheses, a punctuation mark we haven't seen yet, and the vertical bar. If we separate character strings by vertical bars within parentheses, this vertical bar, much like in some programming languages you may have seen, stands for OR, right? We're saying, please match on the literal characters RS, or R, or S, right? So in this case, I should get capital MR, MRS, S, MR, MRS, right? And again, if I throw in that string that was throwing us off before, MSS, right, that does not match because it doesn't match this pattern here. Capital M or lowercase m followed by RS or R or S. This is another situation where Python is going to work from left to right, from the beginning to the end of your pattern string. So for example, when we're matching our Mrs. Baker here, we'll see it matches MRS. And so it found a capital M, and then it saw an RS, and then it was done, right? It didn't even look for these other 2 matches. If we order these in a slightly different order, right, RS or RS, and match against that, we'll see that our Mrs. Baker match is instead turned into just an MR match, because we found a capital M and a lowercase r, and then we were done. We didn't look to see if anything else was valid. So this is a case where things are taking precedence, working from the beginning to the end of our pattern, rather than working by greediness, as Chris pointed out earlier, right? We're just sort of, the first match we find in these categories of OR matches is the one we take, and we just move on from there, right? Okay, so we're making good progress. Now we can match Mr. or Mrs. at the beginning of our names. And also, I should say, I know that gender and honorifics are more complicated than this. This is a very simplified example, and for anyone who does not fit into Mr., Mrs., or Ms., I apologize that you are not included here. I didn't think about that until just now, but that's on me. So, sorry about that. Let's finish out this example so we can move on. So what we'd then like to match is possibly a period after these honorifics, right? So some of them have them, some of them don't. The knights are not amused. I believe, this is enforcing a real strong gender binary that I am guilty of enforcing myself as a cis hetero man. But yeah, knights and doctors and other lawyers, I guess, are also, you can call me up and let me know how you feel about this. So to close this out, we'd like to say, okay, this pattern should match whether there's a period here or not, and we know how to match against 0 or 1 of a thing. We use our question mark. We know our period is a magical character that can match anything, so we want to say slash period. We want to escape that and say, no, I'm talking about just a literal period here. Then we want to match just a space, right? We want a space between our name. And then I would like to have any number of word characters followed by some other non-word character, right? So I will say any number of word characters, at least 1 though, please, not just 0, followed by a non-word character, right? So this is going to match the last part of our name, and then this non-word character is good because it's going to match a white space or a period or what have you. So if I run this, now I get our 5 names. Mr. Anderson, Mrs. Baker, Ms. Campbell, Mr. Davis, Mrs. Ellis, and any other names that are in that format. Looking over my cheat sheet to see if there was another way that I decided to solve this. No, I think that's going to be just fine. So that is the gist of working with these OR alternative classes here, these character groupings. That allow us to sort of have alternatives instead of just a single choice of a character inside of a character set. Questions? Comments? Issues? Concerns? Let me see here. What is next? I know we're going to feature next. And that's why I don't have a pre-made example for this, so I think this will be quite good. Let us pull some data in here. Maybe this is the time we start pulling on the data that I've been generating for the past day, which is going to be quite a lot. So let's have a look at it. As I sort of mentioned at the beginning, for those who are popping in just midway through, I was running a bit of code on the Raspberry Pi with a passive infrared sensor and this temperature and humidity sensor, just gathering a bunch of data for us to work with. It's not very interesting data, as it turns out here, because the temperature and humidity don't change that much over the course of a day here, but that's all right. Yeah, very good. So here is what the 70,000 lines of our data look like. Most of them are temperature and humidity readings taken about once a second, temperature in degrees C and relative humidity as a percentage. And then when the PIR sensor was triggered, it will say something like, and I'll find a message for you here, saw new motion at PIR at, and a timestamp there as well. Let's see, what I would like to do is maybe do something like find the minimum and maximum humidity in the room and give me the timestamp of that, right? So the first step in solving a problem like that is I'm going to need to pull out the temperature and humidity data and the timestamp from each of these lines, right? So let's see how we can use regular expressions to help with that. I'm just going to minimize that, and we will start a new file. Like I say, I'm writing this. Oh, you can't see anything. Well, now you can. Let's try that again. All of this data, which was not super interesting, is a timestamp, temperature reading and humidity reading, and then when the PIR sensor sees new motion, it says something like, saw new motion on PIR at timestamp, right? That's what that data happens to look like. So let's do some processing on this. So here's how I would approach something like that. Let me open up a new program. I'm going to import our regular expression library. And let's say, so I want a pattern that's going to pull out the data from a line that looks like this. And why don't I just copy and paste a random line in just so we have a reference. Thani uses, it's asking me to replace tabs with spaces. That's all right. Sure, I can replace tabs with spaces. That's fine. And we'll save this and we'll call this data parsing as our example. Right, so from this, what I'd like to do is really extract this number 19 and this humidity number here. So what I'm going to do is write a pattern that matches that. It's going to be some kind of raw string. I guess be re.compile some raw string, r. And I will say, we'll do something with it once we have established it. And just so we can see what's going on, I'm going to use the re.search function. Here we'll have to come up with what our data actually looks like. In fact, maybe our data, just for testing purposes, is just this string, right? We'll just take a random line from our log file and we'll parse it first, and then we'll work on, getting all 70,000 lines of our log file in and parsing them one by one when we know this works, right? So let's create a pattern that pulls out the information we need, right? So to match the temperature data here, right? I know my data is all relatively well formatted. I know it's going to look something like the words. Something just fell in my workshop. That's fine. So it looks something like the word TEMP followed by a colon, followed by one or more digits, let's say, followed by the number C. So if I run this, hopefully I will get, yes, so I get a span, the words temperature, 19, and C, right? And similar, I could do the same thing for humidity, right? I could say pattern equals re.compile, raw string humidity, at least one digit, and then the percent sign, right? If I compile that, I should get the humidity as well. And I could combine those into a singular pattern, right? Something like this. Oops, that's a little bit much there, huh? I could say I want the character C followed by one or more white space characters, right? This /s again stands for space. Followed by humidity, followed by some characters, and D. So if I match on that, I should hopefully get temperature and humidity data all matching out. But really what I'd like to get out of this is not just like this string, temperature, humidity. It'd be really nice if I could just extract the numbers 19 and 32 out of our example. And thankfully, Python has or regular expressions in general have a way to do that, and it's reusing the parentheses that we saw earlier. If we put parentheses around a singular character set, or really any character set, the same thing will happen with this, alternate options we saw earlier, we are going to be able to refer to the characters that match what's inside the parentheses as a group, a capture group they call them later on. So let me show you what I mean, right? So because I want to ultimately extract these sets of digits from my string here, I'm going to surround those parts of the pattern that match those digits, right? One or more digits in parentheses. Now this won't change how anything matches, right? These parentheses I told you way back at the beginning are special characters. They're not sort of treated normally. And when we want to search for actual parentheses, we have to escape them, right? So just adding parentheses doesn't change anything. But what they do allow us to do is, if I assign, say, the results of my search function to a variable, right? I can say, print that variable out, right? That looks just the same as we've been seeing. We have our match data here. But now that I have some capture groups created by these parentheses, I can say print match dot groups. And inside, I get the characters in my string which matched the parts of my pattern which were inside parentheses. Let me say that again, because that's critical. What I get returned to me as these capture groups is the parts of my original string which matched the capture groups that I defined by putting them in parentheses. Yeah. So here in this case, I said match is equal to search my data for this pattern, and when I use the groups function, I get back a tuple. In this case, with the characters 19 and 32, because that 19 matched my first capture group here of one or more digits, and 32 was the match that it found for one or more digits here, right? We can see also, let's say I made this capture group here, one or more digits followed by the letter capital C. If I run that, now my capture group includes that letter capital C. Right? But that's probably not what I want. I want to just treat these ultimately as numbers, so I'm going to keep my C outside of my capture group there. We can also, I should say, in addition to the groups method that just gives you all of the groups, I can use the group method, singular group, and give it a specific group that I want. So in this case, if I ask it for group 1, I get the first capture group. If I ask for group 2, I get the second capture group. If I ask for group 0, it will give me the entirety of the text that matched against this pattern, right? So I'm back to having this full temp string. If you just use the groups method, it will assume that you found a match. You don't need match 0, so it just gives you match 1 and match 2 for what it's worth. If you ask for group 3, let me show you. No such group. Yeah, you get an error. I should also say, because we've been very successful so far, let's screw this up here. Right? Let's put a couple of typos in our match here. in our pattern. And I'll say match equals search, print match. When your search function or your find iter function or anything that's taking your pattern and your data and looking through them, if there's no matches, you get a none type result. And so it's very common to see something like, yeah, it's a bad typo. Let's say the cat got on the keyboard. For m, let's see, if match is not none, print match, else print no match was found. Run that, and I should get no match was found. This if match is not none, then do something with it. Otherwise, we didn't match anything, do something else. That's a pretty common pattern working with something with regular expressions. So that is the basics of capture groups. By surrounding parts of our pattern in parentheses, we allow ourselves to have access to the parts of a string which match that part of the pattern after we find the match, right? So in this case now, so we said match is equal to search, if match is not none, print match, and again we have our same match here. You notice that these match objects, when they print out to the screen, we're just saying, hey, print out this match object. We don't get a printed reference of what those groups are, but this match object still has those groups objects within it. They just don't print by default, if that makes sense, right? It's not that they're not there in this original representation. Just when someone was defining how you should say, if you just say print this match object, they said, well, okay, well, the span and the text is all that we're going to clutter up the screen with. That's all that's going on there. Yeah, cool. I need one more hydration break, and then I want to dive into parsing some of these. I want to get a little further in parsing our data that we are working with there. Okay, so now, just one more break, and we'll see. We'll see how we go. So let's see here. Let us deal with the process of getting our data into Python. I'll say with, let's see, do we want to bring it in? I think what we want to do, I mentioned earlier that the find iter method brings in, it creates an iterable as opposed to a list. And we've touched on this very briefly in previous weeks, but the gist of it is, if you have an object like we've seen before, like for I in range a gregillion, right? Python is not going to, in the backend, create a list of gregillion numbers and go through them one by one. The range function creates an iterable that just says, when you ask it for the next number, it's going to give it back to you. And so way you instead of having to have a memory footprint of all gregillion numbers, you have just a small function that says, you know, hey, if I ask you for the first or the second or the third in your iterable, can you give it back to me? And this iterator object will do that. Similarly, the find iter function of our RE library doesn't return all of the matches as a list. It returns an iterable that will give you back each successive match in turn, just to minimize the amount of stuff that has to live in memory at any given time. And why I bring this up is that with a text file of 70,000 lines, I really don't want to have to bring all of that into memory at the same time. What I'd like to do is process it line by line as I read it in from the file. So I'm going to say with open, what is our path for this? With open, Adafruit python dht/temp log.txt read as in file. I guess let's just make sure that that opens okay. It's the Adafruit python dht folder is because that's the library I'm using to read the little temperature and humidity sensor here using their CircuitPython library. Oops. I've unplugged my PIR sensor, but I guess it doesn't matter. We've killed the data logging for the moment. So let's just make sure that that file opens. Yes, that seems to do. And I'll say for line in file, if, I guess I'm going to need to move my pattern up a little bit to where I can actually work with it. I can get rid of this. Let's just comment out this sample line here. Maybe we'll need it again. And I will say, if re.search, my pattern is going to be my pattern, my information is going to be my line, is not none. Print. Well, maybe we don't want to print out 70,000 lines to the screen. But let's say lines that match pattern is a new variable that equals 0. And if our search returns something, right? If it matches that line, I will say lines that match pattern plus equals 1. And then at the very end, I will say print lines that match pattern, lines match our pattern. Why would you need so many data points? So I was interested in gathering temperature data and humidity data at 1 second intervals because I teach these so-called Python classes on Sunday nights, and I was looking for a big data set to work with. That's really the only reason. It's very silly, but that's why. You asked. No, there's no reason to do that. I just wanted something to work with. So let's see if this code works, right? So if I run this, we see that of our 70,577 lines, 68,501 lines match our pattern. Well, that's a good sign. So a bunch of lines match the pattern that we created earlier that has our temperature and humidity data in it. So that's quite good. So now, let's, instead of just totaling them up, let's extract the data from it. So I'm going to say, let's get rid of our, we'll get rid of our counting variable here. That's just for interest's sake. And I'm going to say maximum, let's see, how do we want to do this? Let's say temps equals 0, 0, and humidities equals 0, 0. And I'll leave a little comment for myself here. Maybe this is 0 and 100. Let's see. I guess you want to be reversed. 100 and 0. And what's going on here, I'll explain in just a second. I will say 1,000 and 0. And I will say represent the minimum and maximum values of these parameters, right? So I have our minimum temperature and our maximum temperature, our minimum humidity and our maximum humidity. Lots of ways you could store this data. This is just how I'm going to store it for now. And I'm going to say, so if we match in our pattern, really what I want is to have access to the capture groups that we define. I want access to that temperature and humidity data here. So rather than doing this search in line, I'm actually going to make this a variable. I'm going to say match equals re.search if match is not none. Right, then I have some data to extract, and I will say temp humidity equals match dot groups, and I think that will be just fine. Yeah, so this is a construction that I don't know if we've explored before, called tuple unpacking or list unpacking. If I know that this object is going to return a list of 2 objects, I can just give it 2 variables, and this syntax, this variable comma variable, will assign each member of that list or tuple to each of these variables. And because I know my order is temperature, humidity, those will in turn take the values given by group 1 and group 2 of our match. Let's see. Well, just to make things a little chaotic, let's print out, to start with, a temperature and humidity of each line. This is going to take a little while because there's 70,000 lines. Yeah, let's stop that. Yeah, but you get the idea. So we're extracting that temperature and humidity data from each of those lines there. I will say temperature 0, so our minimum temperature. And actually, maybe there's a way to clean this up. Sorry for jumping around here, but like I say, we're writing this live. Storing this as a tuple here, as a list of 2 items is not maybe the clearest thing. Maybe what I'd like to do instead is say have a dictionary indexed by some strings, right? So I will give it some names here just to make it a little bit clearer what's going on. Humidities equals a dictionary. Key is min. Minimum value was 100, and the maximum value starts at 0. And I want these minimums and maximums to be relatively low and high respectively so that any actual values aren't swamped by them. Chris wants to see all that data. Chris, if you want to stick around for the after stream, I will just be scrolling that data on screen for the next 8 hours. So that's just for you. So I will say temperature with a key of min equals minimum, and that's a built-in Python function of temperature min and the temp that we just read, right? So if our read temperature is lower than the current minimum temperature, that will become the new temperature. Otherwise, no change. And we'll need 4 lines, much like this. If our temperature max is going to be the maximum of our previous maximum temperature and the new maximum temperature. And then similarly, humidities. that what I called these? Temps is what I called that variable, not temp. Temps is that dictionary. Temps and temps. In fact, before we do the humidity, maybe we make sure this first one works as well. Doesn't run into an error there. Less than or equal to not supported between instances of type string and int. Okay, yes. So here's an issue here. Let's have it print out our match before we have it do this processing. I'm going to have it print our temperature and humidity like we did just a moment ago. In fact, I can probably just scroll back up in our timeline to the moment where we were printing all of this, and we'll see, well, we can see that they look like numbers, but if I have it print them out straight from our groups method, we'll see that, of course, these are being parsed from a string. And so what we're getting is not the numbers 20 and 35, we're getting these strings 20 and 35, right? And that was the clue that I got from this. Not less than or equal to not supported between instances of string and integer is somewhere I'm trying to treat something like a number that is in fact a string of characters. So instead what I'm going to do there, let's see, there's a few different ways I could structure this. I could say temp equals match.group1, and then I want to turn this whole thing into an int. Right, I'm going to cast that to an integer, make it a number. I can say humidity equals int match.groups2. Right, that'd be a perfectly valid way. Into argument, dot group 1 and dot group 2. Right, that's a perfectly valid way to parse that. That runs just fine. Right, that's one way we could do this. Another way you could, we talked about list comprehensions in our chat about the Advent of Code a few weeks ago. I could say temp humidity equals int m for m in match.groups, and I would want to unpack that a little bit here. Ooh, maybe I can't. Yeah, so that's fine. So this is an example of a list comprehension that we looked at a few weeks ago, right? And you remember, for those of you who weren't here, for those of you who need a refresher, this syntax says, okay, I'm going to create a list, and we know it's going to be a list because I have these square brackets here, much like when we're defining any other list. And I'm going to iterate over all of the items in this iterable, right? This could be this match.groups function, could be the range function, anything I can iterate over. I'm going to sequentially call them this variable name. I'm going to apply this operation, and then I'm going to store that as the successive members of my list. So as another example of a list comprehension, I could say my even nums equals 2 times x for x in range 10. Right, that would go through the numbers 0 through 9, like a range function does, call each of them x, and then add the value 2 times x to our list in order there, right? That's all a list comprehension is. This is a compact way to step through the elements of an existing iterable or list and apply an operation to all of them. So this, I think, is how I would choose to write this, but the other way is just as good and just as clear. So now that we know that this code runs, let's do our same operation on our humidities. All right, we'll see humidities min equals min temps. Oh, it's not temps. Humidities min humidity, and humidities max equals max. And I'm just going to copy and paste the rest of this because what is good programming but copy and pasting. And then at the end of this, I will say min and max temps were temps min and temps max close. Oh, I guess so a little point here. Because I am using straight quotes to indicate the boundaries of my outer string, I can't use my straight quotes, my normal quotes, my double quotes in here to indicate my dictionary keys. I have to use these single quotes. So you recall that single quotes and double quotes in Python are equivalent, right? They're all, you can use one or the other, but in this case, it's useful to have access to them both because I'm saying, okay, this whole string is captured by these double quotes. If I want to use more strings inside of it, I'm going to use these single quotes so it doesn't get confused where the string is actually stopping. right? And then we'll do a similar statement for our humidities. Were humidities min and humidities max. All right, let's run that. Oh, F string expected. Oh, something's gone wrong. Oh yes, I made a typo. I forgot my closing curly brackets. Not uncommon. Go parsing data. I see the minimum and maximum temperatures were 19 and 22. And the min-max humidities were 30 and 32, which doesn't quite ring true to me because I feel like we saw some 33s in here and some 34s. Yeah, something is wrong. Okay. Some of you may have spotted this before me. I should be comparing to our maximum humidity here. Let's run that again. There we go. Minimum maximum temperature. My office space here went between 19 and 22 degrees Celsius and between 30 and 39% relative humidity. Riveting! That's that gripping, high action, high octane Python programming that I know you come here for. He uses C. Apparently, the manufacturers of the DHT sensor use Celsius in that case. So that is one little practical example of how you can use regexes to parse text, right? So we have 70,000 lines of text here to parse, but there's a few advantages we get from parsing it with regexes. It's supposed to like doing maybe a for loop over each line, right? All of our comprehension of each line of text is encapsulated by this pattern that we defined at the beginning. And if we needed to, ingest data in a slightly different format or with more flexibility, we could just modify this pattern up here. Everything else is essentially stepping through, each line in our input file and using the data that we gather about that line. And then we just have to, we spend a bunch of lines developing that data. We want the min, the max, the average, the running average, the trend, and so on, right? All that is program logic. And so none of this is terribly complicated. It's just wordy. But the power of the pattern matching engine in regexes allows us to basically make the text parsing part of this problem a line for a pattern and a line for a search or a find all or find iter function that does it all for you. So that's a pretty decent practical example. Yeah, I want to get to our next practical example because it actually relates to Advent of Code. Tangent. Can you write the code to convert that? Oh, to convert degrees C to degrees Fahrenheit? Sure, absolutely. Let's write it as a function. This will be a nice little break before we dive back into one last giant regex example. Let's write a function to take C to F. So we'll define a new function called C to F, and it takes a variable called degrees C. So degrees C, I'm just reasoning out here, degrees C range from 0 to 100. Degrees F range from 32 to 212, right? So degrees F equals, so we're going to need to do both sort of a scaling operation to stretch the Celsius temperature scaler out to Fahrenheit, and also sort of a re-zeroing to start instead of at 0 to start at 312. So we'll take our initial degrees C variable, and we're going to scale up from the range from 0 to 200 to 32 to 212. So we'll do that by multiplying by a factor of 212 minus 32 divided by 100. Right, that's sort of going to take our individual Celsius degrees, sort of 1 degree of Celsius, and scale it up to the equivalent number of degrees of Fahrenheit. In this case, I think it's 1.8 degrees that this ends up being, but we'll leave it in this form because that makes it a little bit more clear what's going on. And then we need to make sure that our scale starts not at 0 but at 32, so we'll just add 32 to that, and we'll return degrees F. And so now, hopefully, if I've done this right, I can just add degrees F, what did I call that function? C2F of temps, and C2F of temps. We'll just feed our previous temperatures in there. Now, of course, we're going to run that whole bit of code again to find them again. We find that our minimum and maximum temperatures were 66.2 to 71.6, and our humidities, well, they don't have degrees C, but they. And here, I'll tell you what. Let's put the letter F in here after these as it prints out, just so it's clear what units we're using. 66.2 F to 71.6 F. Right? Did that sort of track, Chris? How we're reasoning out what this math would be. We're sort of taking our small temperature range, scaling it up a bit to our larger temperature range, and then shifting it over by a few. So that's a useful function there. We also, for something this compact, I wouldn't necessarily do this as two separate lines. I might just say return this value, right? A little one-liner function, basically, and that will work just as well. Now that we go back and clean that up. Cool. I need to wet my whistle one bonus. Well, I know I said one more time probably 17 times already, but I swear, the next example is a fun one. Hello, Jeff speaking. Hey, Nate, how's it going? Thank you, Nate. I appreciate that. That's what the bat phone is for. Awesome, man. I will take care of that. That's what the bat phone is for. I never do remember to unmute. I'm usually... Yeah, I know I've been prevaricating on it. I need an indicator in my face. Like, even the method of leaving my hand on the mute button is not clearly sufficient. Man, we've been doing this for almost 10 months now, and I still don't have it down, but here we are. Tilt mute koozie I do like. Like, if I pick up the beer, it mutes, and I put it back and it unmutes. That's clever. I do like that, Chris. Maybe that'll be a fun project for a future week. All right. Thanks for bearing with. I mean, fingers crossed, and not to deny it, the technology has held up remarkably well. The Raspberry Pi is holding up. The microphone, I think, well, the microphone itself is holding up. The user error is not holding up, but so far we're doing okay. Let me, before I take you over to computer view, let me pull up this Advent of Code challenge, and we can have a quick peek at it together. There we go. So, there's lots of fun story built in here, but the gist of Advent of Code Day 18 is that you are meant to evaluate the value of various mathematical expressions that it gives you in your input file as text, except the order of operations is not the traditional PEMDAS that we all learned in school. They are evaluated, first of all, strictly left to right, right? So something like 1 plus 2 times 3 plus 4 times 5 plus 6. You evaluate 1 plus 2, then the results 3 times 3, then 9 plus 4, right? We're not doing multiplication first and then addition, subtraction. We're just evaluating strictly left to right. We can also introduce parentheses into that if we want to, right? So we could say, for example, in this example that they give us down below, could say 1 plus 2 times 3 plus 4 times 5, right? The parentheses take precedence over the left to right evaluation, but other than that, addition and multiplication do not necessarily take precedence one over the other. It's strictly left to right. Let's see, Thomas says, need to have an AI that watches your face cam and monitors the volume. Ooh, man. So these are kind of the two different ends of problem-solving spectrum, right? On one hand, one hand is just me remembering to press a button. The slightly different hand is like basically a switch, or maybe a tilt switch. Maybe it's a tilt switch glued to the can every week. I don't know. Some basically it like sends a keyboard message to the streaming software. And then there's Thomas over here on like the digital vision end doing real-time vision processing to figure out what the hell is going on over here. None of them wrong. I appreciate the spectrum of answers that nerds are capable of when put to, well, some chicanery by me. It says mute button that's momentary instead of top. Oh, so I have looked into a momentary mute button. It's actually a little bit difficult to implement on the Stream Deck. Although maybe I'm misunderstanding something, but I don't think there's currently functionality for one function on press, one function on release. There's just toggle. I might be wrong about that. If I'm wrong, somebody let me know. As I describe, Ken says a hardware button. Yeah, that would really be the way to go. And as long as we're there, it's just I guess being unmuted for some beer sips would be preferable to not having anything. Palmer says, hey, Palmer, drink with the mic on. I mean, that's also possible. I don't know how awful it is. I don't really want to find out. But I appreciate your constant exacerbations. No, that's the word I'm looking for. I'm looking for your constant telling me that things are going wrong. Nate, thank you for the phone call. That ringer just sounds really good. So I love, even though I now rings when things are going wrong, that actual bell just sounds so good. Thank you, Nate. What I guess I'm saying is I appreciate your regular expressions of concern for my microphone. And speaking of regular expressions, let's look at this problem from Advent of Code. So we're looking at strings like these, right, where we have some string of operands and some strings of some parentheses and some digits or some numbers, right? And we are going to go through the process of evaluating these expressions as numbers. Now, if we were obeying order of operations, there are ways of just feeding in an expression with some operations built into it and just saying, hey, Python, evaluate this like it's a mathematical operation. That's a solved problem. But this sort of like plus and times are equal in precedence and we go left to right, that's a new challenge, and so we have to solve for that. So one way we might approach solving this problem is, okay, well, if I have a string like these, what I first want to do is evaluate any sets of parentheses that are in them until there are no parentheses sort of left, and then I can evaluate strictly left to right. So let's find the innermost set of parentheses that we can evaluate, right? So in this case, I'd want to evaluate either 2 times 3 or 5 plus 6. In the second case here, I'd want to evaluate this entire, solve this entire string and then add 5 to it. So how are we going to find an innermost set of parentheses using regular expressions? Well, we could do, see, I left it as an exercise for the reader. I left my pattern blank. Right, I'm going to define a function that says find inner parentheses of a given string of an equation. So let's write this pattern together. Well, we know we're going to have to match against some parentheses. So let's start with that. So I'll say I want to match against a literal set of parentheses. So I can't just say, open parentheses, close parentheses, because as we know, that defines a capture group. What I want is to escape those two characters and say, no, match me a parenthesis and a parenthesis, right? Now, as written, right, that's not going to return anything, right? And down here, I'm going to say find my inner parentheses for equation 1 and equation 2 that I've defined up here. Let's see. And then actually, I'll tell you what, I'm going to cheat a little bit. I'll just throw an exit function in there. And up at the top, I'll say from sys import exit. Just so we'll cut off our execution halfway through here. And we'll see, to start off with, that that current pattern doesn't match anything in equation 1 or anything in equation 2 because it's matching an open parenthesis and a closed parenthesis right next to each other, which is not what we want, right? We want parentheses with something in between them. So let's start to expand this out a little bit. Let's say maybe it's any character and it's one or more characters in between them, right? We don't want a set of empty parentheses. We can run that, but now we have the problem of course, Python is matching greedily, right? So in the second equation here, it's gotten the answer correct, right? There's only one set of parentheses and it found it, right? An open parenthesis, any number, at least one of any character and a closed parenthesis. But up top here, to Chris's point earlier, right, it's going to match the longest possible string in its input that matches our pattern. So an open parenthesis here and a closed parenthesis here and everything else in between, as long as that string is as big as possible, that's what's going to match. So really what we'd like to match is a character set that is not, and I don't know if I actually need to escape the parentheses inside this character set, so let's find out. If I just say not open or closed parenthesis, I think that's going to work, yes. So I'm going to say, okay, match me a literal open parentheses followed by one or more of the character set that is anything but a set of parentheses followed by a closed parenthesis. And of course, up here in our first equation, we found that it found the first match 2 times 3, and our second one, it still finds our overall match here. If I wanted to find all of the possible matches, I could say return search.find all, right? And we'll see that it finds all the sets of parentheses that have no parentheses inside them. In our first equation, that's 2 times 3 and 5 plus 6. In our second equation, it's this long string of parenthesesy things, right? So we've sort of built up a simple pattern for finding the inner set of parentheses, and then it would be up to us to apply some logic to, take a string like open parentheses 5 space plus space 6 close parentheses and evaluate that into the number 11, for example. So that's a simple pattern to deal with that challenge. Let's look at the second part of this challenge here. So we now have the ability to identify an operation within a set of parentheses that we could, potentially solve. So now that we have a string like 5 plus 6, or 2 times 3, or 8 times 3 plus 9 plus 3 times 4 times 3, right? It'd be nice to be able to break that down into, say, a number, an operation, and a number, starting from left to right, so we could actually do some math on it. So let's create a regular expression that will find the first two numbers and the first operation in a string like the ones we've just found, right? And again, I've left this as I say an exercise for the reader, it's really an exercise for the me in this case, because I'm the one here typing. So let's write a regular expression that would find these numbers here. And just to make things a little bit more interesting, why don't we juice up our equations here so that not all of them are just single digit, right? Let's make these a little bit more complicated here, and I'll add another digit there, right? Just to make things a little bit more interesting. Let's see. Oh, I used different sets of equations down here. Okay, because this is going to assume that we found a set of equations with no parentheses in it. So now how are we going to find the first two numbers and the operation there? And look, I already gave myself multi-digit numbers here. How nice of past me. So let's write a regex here, a regular expression pattern, that will match and give us the data for our first number, our second number, and our operation here. Well, we know it's easy to match numbers, right? You could say one or more digits, or one or more with a plus sign, and digit numbers with D, followed by a space, followed by either a plus or a times, right? Those are the two operations that are allowed in our problem set. So I'll just say plus times is our character set, followed by another space, followed by one or more digits. Now if I run this code on that, what we'll see is I get out here our match objects consisting of 4 plus 634 and 51 times 7. But let's say, just to make my life a little bit easier down the road, I'd really like to have access to those two numbers in that operation. So we'll surround each of these things that we found in a capture group using our parentheses here. And rather than returning our search pattern here, what I will say is if, let's return our match is going to be equal to a variable. We'll set it just so we can work with it here. And we will say if match is not none, return match.groups, else return none. Right? So now we're getting not just the strings that match, we're getting the individual numbers for the symbol plus and 434. We're getting 1 and times and 7. Right? And then we could move on to do something like start to process these functions here. I could say process first two of string will be a new function here. Process first two of is pretty descriptive, and we'll say of our equation. And I will say, in this case, match, let's see, groups equals find, what do I call this function? Find first two equation, right? That'll find my first two numbers and my operand, my plus or my times symbol. And I will say if groups is not none, if groups 1, right? So that the 0th member of a group is having to be plus or times represent our operation here. Return int groups 0. Let's see, if groups 1 is plus, return int groups 0 plus int groups 2. Else if groups 1 is a times symbol, return int groups 0 times int groups 2. Else, in this case I'm going to do something we haven't seen before, which is raise our own error. I'll raise a value error and say unknown symbol. If I have anything but a plus or a times in that space, I really want to stop my program and know about it. Unknown symbol, and I'll say groups 1. We'll just print that out to the screen because something's gone horribly wrong somewhere. So let's see here. Why don't we print, what did I call this function here? Process first 2 of? Yeah. Print process first 2 of EQ3 and print process first 2 of EQ4. And I'm going to get rid of my earlier print statements just so we're only looking at the second part of this problem. Comment those out. So now what should happen here is we're going to give it these 2 equation-like things that have no parentheses, right? We're assuming we've used our earlier function to find a set of operands with no parentheses in it. And then I'm going to find the first 2 numbers in it and the operand between them, right? That'll print out first, and then it should print out the result when we apply that operand to these first 2 digits. In this case, 4 plus 634, and in this case, 7 times 51. Let's see if that works. Ah, we got an error. Let's see here. Process first 2 of oh, I need the def keyword here so it knows we're trying to define a function. That seems perfectly reasonable. Let's try that again. End of known. Oh yes, another typo. This is about how things usually go when I'm writing code. At the end of my print statement here, I'm just missing a quotation mark. There we go. So now, yes, we can see it found that in my first equation here, my first 2 numbers were 4 and 634 and a plus sign. When you add them together, you get 638. In the second equation here, my numbers were 51 and 7, and the operation was times. And now I have 357. The process of solving this this challenge in Advent of Code essentially boils down to identify the innermost set of parentheses using something very much like our find inner parentheses function, right? Then applying our process first 2 of function to turn those strings of numbers inside parentheses into a value, and then repeating that over and over until there are no parentheses left, and then you're left with a single value, and that's your answer. So in this way, you can see again, like, the process logic for what to do in each case can still be a little bit involved, right? We still have to sort of say, okay, plus means plus and times means times. We'd evaluate those by hand, but we've sort of taken all of the complexity of splitting up an equation like one of these, which on its head might be a little bit hard to do with for loops or other structures, and condensed it all into a, what is not necessarily a readable at first glance pattern, but all of the logic dealing with processing and ingesting text is baked into this pattern right here. And that really is the power of regular expressions, is they take the ability to match against complex patterns of strings and encapsulate it into a concise part of your code. And now you know all of the parts you would need to start to unpack something like this if you encountered it in the wild, right? So, okay, what is this pattern matching against? Well, I know /d is a digit. Okay, plus is 1 or more, and this is just a capture group. Okay, so we're looking for 1 or more digits, a space. Here's a character set, and that's of plus or times. So 1 or more digits, a space, plus or times, a space, 1 or more digits. Okay, now I can start to understand that. And similarly up here, even though, like, to my eye, this kind of just bounces off as a line of squiggles, we can start to sort of break it down when we get to it. It's like, okay, well, we know we're escaping something. Okay, so we're looking for an open parentheses, and here's a character set that is not parentheses. 1 or more of those, and a closed parentheses. Okay, so anything that's not parentheses within parentheses. All right, I can understand that as well. So basically, you have all the tools at your disposal to start unpacking regexes and using them to solve your own problems, if that makes sense. Real quick, maybe we'll flash over to the full code of the Advent of Code question that we're solving, and I'll show you how this sort of shook out for those who are curious how you'd apply this logic to the ultimate problem solving, and then we'll wrap up. So, because I have to actually launch VS Code now. That seems reasonable. All right, here. Did I have this up earlier? I did. How clever of past me. All right, now I think before I start, of course, I'm gonna have to blow up this text size because that's pretty minimal over there. Let's blow this up to like double what it is here. Oops. Oh, debug console. Oh, editor font size is what I want to make things bigger. There we go. That's a little bit better, huh? So we can see here in this original problem, I defined a function much like we just saw, find inner parentheses. And I used a slightly, actually, I did escape the parentheses here, although we just learned that we don't have to, so I've learned a thing. And then I defined a function, called eval left to right, right? And again, that's going to find the first two numbers in our string and the operation between them. And you see it's slightly different from the one we just did, but you know, very similar. We have our any one or more digits, right? At either end, one or more digits. We have a capture set that's going to capture that information. And rather than putting a hard-coded space, I said any number of white space in between them. So the space character, remember, matches any number of spaces, and this asterisk says, you know, any number of spaces in between them, followed by a plus or a times symbol, followed by spaces, followed by digits. So very similar to the pattern we just saw. Now it says if s equals none, right? So if our search does not match our equation, you know, we can't find a digit followed by an operand followed by some digits, we can assume that our equation is probably shrunk enough that it's just one number anymore. And so we'll just return that number, that string of a number represented as an actual integer. So return the integer value of whatever our string is left with, right? And once we return, we're done, right? But so if we don't return, we know we must have matched something. We have two numbers in an operation, right? And here I'm just explicitly taking our first number, our second number, and our operand, and getting them out of our s.group operator here, much the same way that we did with our list unpacking earlier. I know this is going to unpack to a list of a tuple of three numbers. I'm going to say, okay, so assign the first result to first, the second result to our operand, and the third result to second, right? And here's very much a similar bit of logic here. If operation is plus, the result is the first plus the second number. If it's times, it's the first times the second number. Otherwise, throw an error because something's gone horribly wrong. And then this is the clever and recursive bit. We say, okay, I'm going to find the first two numbers. I'm going to find the result when we add or times them together. And then I'm going to return not just that result, but that result followed by the rest of the equation that was passed in. Yeah, so I'm going to make use of the fact that the matches give us the position of their matching text and say, okay, well, if I have here, I'll show you over here. If I have a string like this one here, right, and I'm going to evaluate. The first thing I'm going to do is evaluate 8 times 33, which, well, let's see, what is that? What is 8 times 33? 8 times 33, 264, right? So the first thing I'm going to do is calculate that at 8 times 33 is 264, but then I'm going to need to continue solving the rest of this equation. And so I'm going to use some string manipulation to turn this function into 264 plus 9 plus 3 times 4 plus, oh gosh, 9 plus 3 times 4 times 3, right? Then I'm going to run the evaluate left right function on this again, which is going to find 264 plus 9 and turn that into 273 plus 3 times 4 times 3, and so on, until there's just one number left, and that will be the final result of our calculation, right? So by moving through these strings recursively, we can sort of, you know, take each pair of starting numbers in turn. As we move through. So that's essentially how you solve the first part of Advent of Code Day 18, is you sort of parse out each individual line within parentheses, and then you evaluate each of those inner functions as you go. The second part of the question asks you to evaluate them with precedence. In this case, what it means is you evaluate everything inside parentheses first, but in this case, your additions take precedence over your multiplication. So I guess instead of PEMDAS, it's Peasmd, P-E-A-S-M-D, Peasmd, yeah. And so, again, a very similar process, but instead of matching either a plus or a times, we first see if there is a plus operation, and if not, we should look for a times operation to do first, as opposed to the traditional times and then plus first. But the logic is very simple. All of this, I should say, I don't think I linked to it, is on my GitHub at Jeffers Glass. You can look through all of my code for Advent of Code for 2020. Happy to share that. I'm at 46 of 50 stars, so if you're interested in delving into how Day 18 works, this would be a good way to take a look at that. Final questions as we close out? I'm going to put my hand on the mute button and not move it away until I unmute as I wet my whistle for what I swear is near the final time. I do want to, as people are thinking of final questions, if they have them, or we're just wrapping up, I do want to throw out a couple of good resources for learning more about regexes. One is, of course, these are both linked in the description of this stream/video, depending on where you're watching it. One is the Python documentation for the RE module, the regular expression module, which is I have it open whenever I'm working with regexes because it has all of the shorthand for, okay, so star is 0 or more, plus is 1 or more, and so on. How brackets work, how parentheses work, and some more advanced syntax as well. Getting down to like all of what these short character classes are, things like, so our friend is /d for digits, /w for word characters, and so on, and various other advanced things, and then all of the functions you can use, to compile your functions, and then various ways you can search through your strings, including search, and we've seen the match function. Apologies, could you recap the phone number? Oh, yeah, I'd be happy to. Let's see, real quick, a couple more things you could use to find matches in your text. Find all we looked at returns a tuple of all just the text and the matches. Find iter, which is probably the most useful. I think just finds every match and returns match objects for them. And then actually the sub function, which we're not going to look at tonight, but that allows you to basically perform matches using regular expressions and then substitute things within that search, right? So if you wanted to go through and transform, like we did earlier, all instances of Mr., Mrs., or Ms. to have the proper capitalization and punctuation, you could do that transformation while searching through things with a regular expression. That's a little beyond our scope tonight, but a cool function to explore. So that's a really cool place to be. The other resource I want to point out, and I don't know how well this will scale to be visible on stream, that's actually not awful, is regex101.com. This is, as I say, linked in the description. It's basically a playground for regular expressions. So it allows you to type in a regular expression pattern up top and some strings down below, and it will show you which of your strings match your pattern, and even more cool, it will tell you why. Maybe, Palmer, this will be a good way to explore the phone number example. Let's generate, I wonder if there's a random phone number generator. Of course there is. It's the internet. Oh, this is for like spamming people. I don't like that. Here we go. This is more what I was looking for, which is random phone numbers that look like phone numbers. Here we go. So there's some data. And this is actually good. This is actually not the formatting I would have chosen, which makes it a little bit more complicated. So let's say we want to match just the phone numbers, but not anything that's not formatted, not like a phone number. So I'll introduce some hiccups here. Things that could be phone numbers, but aren't. Palmer, I misunderstood. What's the phone number in the lower third? Yeah, okay, that's totally fair. Palmer, that phone number is this beautiful phone just here. Yeah, Palmer, you should have just called. That's the phone number that Nate rang earlier. That is, it's an old AT&T rotary dial telephone that I acquired that has an actual dial tone that hopefully you can just hear there. It's just so silly, but it gives me such great joy to actually have like a ringing bell dial tone phone in my workshop now. And it has a nice red handset coming for it too to match. So that's all that is. But now that I've started on this example, Palmer, I can show you what just a little bit more about this you can use this phone number example that I thought you were talking about to demo regex101.com just because I think it's really cool. Oh, that's not what I want. That's what I want. Hi. So for example, right, let's say we're going to start developing some regular expression to match these phone numbers and not others. Let's put in a little bit more non-phone number data. So you might think like, so let's start from the beginning of the string. I'm going to have an open parentheses followed by 3 digits /d/d/d and a close parentheses, right? Now look at all this cool, let's see if I can zoom in a little bit more. Look at all this nifty highlighting it's doing, right? So it's telling me that match 1, match 2, match 3. It gives me the position within my string. It gives me the text inside that it's matching. And this is the cool part, over here on the right under explanation, it tells me, okay, well, DDD, here's how it's matching. Slash parenthesis matches the character, open quotation marks, literally. D matches digits, and matches close parenthesis there. Then I'm going to match a space. Then I'm going to match, say, 3 more digits, and we could do that in another way. We could say slash D and exactly the number 3, as we saw before. And as I start to put in these capture groups here, because assuming I want to capture these parts of the phone number, it will also give me information about the capture groups, right? So as I scroll down in the explanation here, it will say, okay, well, here's our first match. In our first capture group, D3 matches a digit to 0 to 9, and it matches it exactly 3 times. Then I have a dash. Then I have, let's say, another digit matched exactly 4 times, right? And it's going to give me that information as a, keep hitting save by impulse. It can tell me that my second capture group is matching things, and I can go into each of my matches and say, okay, well, for this match, the overall match is this, capture group 1 is this, capture group 2 is this. So it's a really good way of exploring what the various parts of regular expressions can do. And if you're having trouble figuring out whether your regular expression is applying to the text that you're trying to use it to, or it's not, or you're having errors, this is a really fun visual way to explore how these things are all working. They also have a neat, it's going to be a little hard to show down here. Oh, it's hidden by me. I'll hide myself. A quick reference guide. So it has, like, if you forget exactly how the quantifiers work, I know this is a little small, they have, like, what does a question mark mean? Question mark matches 1 or 0 of something, and so on. It has various other references for how the regular expressions work. In this case, you can choose which flavor of regexes we specify. Chris mentioned, hit on earlier, I think Kenneth caught, like, there are slightly different variations in syntax between various programming languages or environments or search functions. So if you select the Python module here, then you'll be matching in the same way that Python 3 matches things. But yeah, if you're interested in learning more, playing around, Regex 101 is a really neat way of playing around. And there's lots more that we have not talked about. Not lots more. There is some more we have not talked about. The biggest one is sort of self-referential regular expressions, which, just to touch on very briefly, just to wet your whistle, so you can continue exploring. Let's say I wanted to match a pattern. Let's say I wanted to find what in the States we would have as all of our toll-free numbers, right? So numbers that start with an 8 followed by 2 identical digits. Well, here, let's introduce some that are, so I have this 866 area code up here. That's a toll-free number, but my number, which is 662 5678, should not match this. I only am going to match 866, and maybe let's give ourselves another toll-free number to match, 888 245 5555. Right, so I want to match those 2 toll-free numbers, but not anything else. So starting with an 8 is easy, right? And I would like to have 2 identical numbers here. So in this case, what I would do is I would say I want to match an 8 followed by a digit, followed by an identical digit. And this is the syntax for referencing a previous capture group. This /1 / any number refers to the text that matches a previous capture group. So this is saying, okay, find an 8 that's followed by a digit, right? So maybe in this case it's a 6, and so it would have to be followed by another 6, or an 8 followed by an 8 followed by another 8. We could also, the other primary topic we haven't talked about is pinning things to, say, the beginning of a string. So for example, in our example down here, we have 888 245 8888. I don't want these 8s to match, just this first area code here. So I could use one of my start of string modifiers, right? I could use a /a modifier. And of course I would have to tell it that there's a literal parentheses in front of it, and that should be fine. Pattern error. Oh yes, there we go. 8. Right, and so now I am matching with, it's interesting. I'm only matching with 866, but not 888 down here. Oh, because I'm only matching to the very beginning of my overall string, and new lines do not count here. So I really don't want beginning of string. I want beginning of line. This is one of those cases where working in contiguous string mode versus multi-line mode is kind of posing me, and I don't know that I can put regex.com into multi-line mode. But you'll see it actually will tell you. It'll say the M modifier causes things to match the beginning of line. So maybe what I want is the ampersand here? No. Yes. I can use the caret in this condition to say I want to match the beginning of a line or the beginning of a string, so that I don't match these repeated 8s down here. I only match things at the beginning of a line. So like, I'm going off on deeper tangents because I'm excited about it. These are all further topics for you to learn about when you're learning about regexes. They are super powerful, and they're pretty versatile across languages, right? We've been talking in the context of Python, but even Regex 101 has PHP, JavaScript, and Golang. If you wanted to write in Go, you certainly could. And there are regex modules and libraries for lots of other programming languages, as well as Chris mentioned earlier, things like text editors and web searches that allow you to search text in a really intuitive way. So I encourage you to go out and play and explore and learn something new about regexes. What have I missed in the chat in the meantime? Oh, yes, I do have an active landline, and I love it. Let's see. Google Voice can ring your VoIP number if you want to. Yeah, so Kenneth and I both have accounts on VoIP.ms for this phone number here, which is super delightful. And it's, yeah, having a real live phone number is really great. I'm working on putting together, I think I originally said last time we were going to talk about like different Raspberry Pi distributions, but I just couldn't figure out, like, it was fun. I've been playing around with Asterisk, which is a free SIP phone routing service essentially, that you install on a local Raspberry Pi, but it's just like I couldn't figure out how to make that general enough to be applicable. So maybe in the future, but the goal is to have both the dial phone and this big chunker sitting next to each other, just because the contrast between, I mean, this is a really cheapy plastic like AT&T Office phone. That contrast just brings me such joy, as does the contrast of not having class to having class on these Sunday nights. Also brings me joy. The transition from spending time with y'all to not having time with y'all after, say, 9:08 p.m. on a Sunday night here Central Time is much sadder than the start of it, but I think that's what we are winding towards. So thank you very much. Next week, on next Sunday, probably next Sunday shortly before the stream, knowing myself, we will have files for the Demi-Lite going public. And that sounds awfully highfalutin. I'm finally just going to put the files out there in version 9.4. Version 0.9.4. It's time to get them out into the world. They work well enough. I have version 0.9.5 is on its way from China. It will probably not be here before next week, so that'll go up shortly after. So we'll do an assembly time. I'm hoping to like publicize that a little bit. And by that I mean put it on Reddit and see if people want to stop by and see how to assemble one of these new versions and talk about what the future features are. Some of them will not be a surprise to those who who have been here before, Thomas and Chris and others. Thomas is going to be milling those PCBs. Oh yeah, if you have other related projects, Thomas, I know, Cookie, if you watch this later before next week, I don't think you're with us tonight, but send me pictures or links or things that you want to like share in this ecosystem. I think it's really fun. And yeah, I just think it'll be a fun time to put stuff out. I am sure that when I put that out, there will be stuff that people are like, that's wrong, or that doesn't make sense, or whatever. I'm excited about that feedback, especially from you nerds who have been here a bunch. So as we go through, I'm basically going to like walk through one more time with the instructions how to assemble one of these things, as a live thing and also as a reference for people. And when people are like, hey, that could be better, that's awesome. I'm gonna make note of it, and we'll go through, and I probably won't make the edits on the webpage live because that's boring. But we'll find a list of things to change and make better. I don't know. That just sounds like a fun old time. And it's been an excuse to get the old 3D printer working decently enough to bide me over until the Prusa Mini shows, and that'll be a lot of fun. So many servos that were underpowered for my Switch project. Yeah, it's gonna be a grand old time next week, and I'm looking forward to seeing many of you there. Thank you so much for spending another Sunday night with me talking about Python and Raspberry things. That seems fine. I don't know what the next Raspberry Pi thing will be in a couple weeks. We'll just have to find out together. Until then, please stay safe, stay hydrated, wash your hands, stay warm, wear a mask. You all know this. You're all good nerds. Yeah, just be safe to each other out there. Get vaccinated if you can. We're in the home stretch of this thing, I have to think. We started this out in the darkest days, and now the light is at the end of the tunnel. We can make it through together, especially when we hang out with good people like yourselves. And I will see you next Sunday night when I swear all that documentation will be done and published, because now I've committed to it. Thanks, y'all. Have a good night.